Essential 2 Fundamentals of Matter. Solids have a fixed volume and shape. Particles are tightly rigid and they vibrate only slightly. Liquids have a fixed volume, but they don't have a fixed shape. Particles slide past each other, which is why liquid flows. And a liquid is going to take the shape of whatever container it's in. Gases have no fixed volume or no fixed shape. The particles weakly attract one another and they move independently at high speed and they expand to fill their container. Pure substances are elements or compounds which have definite properties. They cannot be changed or altered by physical means. Elements are pure substances that contain only one kind of atom. They cannot be broken down any further. So if you look at the image, you can see the helium element, the element helium, there's only one kind of atom in that little circle microscope thing, and it's those blue atoms, only one kind. Elements are represented by their atomic symbols. If you look at the periodic table, each element has at least one capital letter, and a lot of them have a lowercase letter. Helium has a capital H, lowercase e. Neon has a capital N, lowercase e. But fluorine just has a capital F. An atomic symbol may sometimes have two letters, but if one letter is uppercase and the next one is lowercase, they're part of the same symbol and represent the same element. Elements are the most basic form of matter that still retains their properties, and every element has its own unique characteristics. Now, this is a depiction of the element hydrogen. You can see that there are only one kind of atoms inside of the blimp. There are only hydrogen atoms. So that substance is a pure substance, and the element hydrogen has specific properties. For example, it is highly explosive. Now, the element helium, one property of helium is that it is lighter than air, and that's why it makes balloons float. Another property of helium is that it is unreactive. Now, helium atoms can be seen in this picture. There's only one kind of atom, and that makes helium an element. Only one kind of atom. So, to review elements, they're composed of just one kind of atom. They are described by their atomic symbols, which have one or two letters. Take a look at the left-hand picture. Copper is an element. It has only one kind of atom. If you look on the right, that's carbon dioxide. That is not an element. You can see there are more than one different kind of atom. Now, molecules are two or more atoms combined together. Now, many atoms exist as molecules. That is, they have two or more atoms combined together. For example, bromine. As you can see in the picture, each bromine molecule consists of two bromine atoms bonded together. Now, it is still an element because it's only one kind of atom. But what makes it a molecule is that they come in chunks of two. And if you look on the right, the oxygen molecule has two oxygen atoms in it. Now, the little number next to the atomic symbol is called the subscript, and that tells you how many atoms there are of that element. So if you look at the oxygen molecule, for example, you can see that there are two oxygen atoms in that molecule, therefore O2. Now, compounds are molecules that are made of different kinds of atoms that are bonded together. For example, take a look at the water molecule. Water is a compound. All water molecules have two hydrogen atoms and one oxygen atom bonded together. So you have different kinds of atoms bonded together. That's different from elements which have just one kind of atom bonded together. Now, compounds are always described using chemical formulas. Chemical formulas tell us which atoms are in a compound and how many of each kind of atom there are. And in the example, the chemical formula for table salt is NaCl. That means that you have one sodium atom and one chlorine atom in a salt molecule. Aspirin is an example of a common compound. You can see it's made of different kinds of atoms: carbon, hydrogen, and oxygen bonded together. Now, mixtures are an entirely different category of classifying matter. Mixtures are when you have two or more pure substances physically mixed together. The ingredients in a mixture are not chemically bonded. Therefore, mixtures do not have chemical formulas. That right there, aspirin, that is not a mixture of carbon, hydrogen, and oxygen. That's not a mixture. Those atoms are bonded together chemically. This is a compound. A mixture is not bonded together chemically. Now, the properties of a mixture are the average of the properties of its ingredients. For example, you have salt, which is, I don't have a better way to describe it, really salty, and you have water, which is really wet and watery. If you mix those together, you get salty water, which is a mixture of saltiness and wateriness. Now, if you look at a compound, on the other hand, the properties of a compound differ drastically from the properties of the elements that make it up. So you have hydrogen, which is an extremely explosive compound. If it reacts with oxygen, which also is extremely explosive, they chemically bond to make water, which is not explosive at all. So hydrogen plus oxygen chemically bonded make a compound called water. Water has totally different properties than oxygen by itself or hydrogen by itself. But if you look at my salt water example, salty water has both properties of water and of salt. That's because it is a mixture. Mixtures versus compounds. If I mix together a cup of red Kool-Aid and a cup of blue Kool-Aid, what would happen is I would get a mixture of the two properties of each ingredient. So red and blue mixed together would give me purple Kool-Aid. I wouldn't get something entirely new. I just have red and blue Kool-Aid mixed together giving me purple. But if I were to react baking soda and vinegar together, I'm going to get something totally different. I'm going to get carbon dioxide gas. That's what's in the bubbles that are formed. And carbon dioxide is a compound. It has properties totally different than the baking soda or the vinegar that made it up. Now, there are different types of mixtures. Homogeneous mixtures have what's called a uniform composition. You can't see the individual particles or ingredients in a homogeneous mixture because all of the particles or ingredients, they're evenly spread out throughout the mixture. For example, salt water is just as salty on top as it is on the bottom. And the Kool-Aid is just as red in the middle as it is on the sides. The particles are evenly mixed out, and you can't see the individual sugar particles inside of the Kool-Aid. That makes it a homogeneous mixture. You can't see the individual salt particles inside of the water. That's what makes it a homogeneous mixture. Heterogeneous mixtures, on the other hand, the ingredients are not evenly mixed, and you can see the individual particles and ingredients. For example, if you look at cereal, you can see the cereal kind of floats on top of the milk, so it's not evenly mixed. There's more cereal on top than it is on the bottom because most of it floats on top. And also, I can see the individual ingredients that make up the cereal. I can see the cereal. I can see the different colors. I can see the milk. If you look at sand and water, the sand is not evenly spread out in the water. All of the sand sunk to the bottom. There's more sand on the bottom of the beaker than there is on top of the beaker. The ingredients aren't evenly mixed, and I can see the ingredients that are making up this sand water. I can see the sand, I can see the water. It's a heterogeneous mixture.